All right, welcome to Physics Lesson 5.07. This is the last recording for this chapter with Newton's calculations. And we have a classic physics problem about Atwood machines. So we have two bodies, should we say two boxes maybe, or masses. One has a mass of 25 kilograms. The other has a mass of, I'm not going to redraw the size, 45 kilograms. And there's a pulley up here. We have a string that comes up and comes over the pulley. And we have to assume that the pulley has no friction and that the cord has no mass. Because if you work in mass and friction, or I'm sorry, mass of the rope and friction of the pulley, that changes things. So we want to know if we're holding these up and we release our hands, what are they going to accelerate at? The reason we're doing this problem is it's an example of a problem that has multiple objects. So some of the other problems you're going to see that have multiple objects is maybe you have a box stacked on a box. Or maybe you're pushing two boxes and you're pushing them this way, and they want to know about the force on this box. So how do you handle it when we have a system that has more than one object? Well, the first thing that you need to do, whether you're working on this problem or this problem or this problem, is to have a free body diagram, FBD, for each object. Because we're going to have similarities here. We're going to have the tension is going to be the same. This is a system. So we know the tensions are going to be the same from here to here. You can't have like one side be more slack than the other. And the accelerations for these blocks, so think about it. Okay, so what did you say was going to happen when we remove our hands? Hopefully you said this side's going to fall and this side's going to lift. So what do we know about the acceleration? Well, the acceleration in its magnitude has to be the same, but in its direction, it's different because this one's going to go this way and this block's going to go that way. So the same thing for this situation up here. If you were pushing this, they would all have the same acceleration, but they might experience different forces depending on what's at play. Same thing here. They're both going to have the same acceleration. They're going to accelerate as a system, but they're going to maybe experience different forces. So you have to understand, and I call that equivalencies. So what's going to be the same and what's not going to be the same. So sometimes we have to look, so this requires us to look at systems versus individual objects. And I could do a dozen problems on just this. We could look at, this problem, we could look at that problem. I think some of these are in the practice problems. And the AP test mostly hits these qualitatively. All right, so let's go ahead and start off with that free body diagram. So I'm going to draw my 25. We're going to assume the 25 is a little bit smaller than the 45. Kind of keep it. And let's start off with the weight vector. Now, this weight vector is going to be smaller than this weight vector, so FW here. That one's got to be bigger. FW. And let's take, for this problem, let's take acceleration and make it 10 to make it simpler. So this is going to have, let's do up as positive. So this is going to have a negative 250 weight vector. This is going to have a negative 450 weight vector. All right, what's the other forces at work here? Hopefully you said tension. So we've got tension. And we know that the tension has got to be the same here and here. But what else do we know when I'm drawing this vector? I'm going to have acceleration down this way. I'm going to have acceleration up this way. So this vector that I draw has to be longer than this vector, but it has to be shorter than this one. So I want it longer than that vector, but it's shorter than this one. And that's going to be tension, and that's going to be the same for both. Now, it's not hugely different, but hopefully you can see this is longer than this, but shorter than this. So this is a correct free body diagram for this system. I can create an equation for each of these. So over here, I know that my net force is going to equal mass times acceleration. Well, what's my net force? My net force is going to be tension minus my weight vector, because it's negative, equals mass times positive acceleration. And over here, I know that I'm going to have Ft minus Fw equals mass. But what's different here? My acceleration is negative. And guys, that makes all the difference. Do you remember a couple of videos ago where I almost forgot to put in my negative sign and I showed you how it made a difference? We have the exact same situation here. Okay, so I'm going to bring over my equations. So this is going to be, so I'm going to do box 1 over here. I'm going to do box 2 here. So this is going to be tension minus 250 equals 25 times my acceleration that's positive. This is going to be tension minus 450 is negative 45A, and I just took the negative and I brought it out front. Well, do you remember back on the pretest, I gave you guys a system of equation problem, and this is why, because we're going to solve this using system of equation. So I'm going to set this equation to F sub t. I'm solving for acceleration, so I want to substitute out this. So this is going to be 25A plus 250. And I'm going to sub this in. All right, since I'm subbing it in, I'm going to switch colors to, color shall I do? How about light blue? So I now have 25A plus 250 minus 450 equals negative 45A. So this is going to give me, when I subtract this over, negative 70A. When I add these two together, I'm going to have negative 200. And when I solve for acceleration, I get 3.6 meters. Oops, wrong one. 2.85 meters per second squared. This side is going to be negative. This side is going to be positive. So they're equal and opposite. What you can do is you can take this back and plug it into both of these equations and solve for the tension, and that tension should be the same. In fact, I did this before I put this problem into video, and I realized I had made a mistake. I had copied down the mass of this box as, I think I did 40 instead of 45, because my numbers didn't match. When you plug this back in, you find out that your tension is, so I put in 2.85 here, and I put in, I'm sorry, let me come back down here. I put in 2.85 here, and this is negative. I put 2.85 here, and that's positive. And when I solve for both of these, you should get that the tension is 321 newtons. So if you plug those back in. So if you were working one of these problems, you'd have 3 free body diagrams. If you were working this one, you would have 2. For this one, you'd have a normal force, you'd have weight, and if this has friction, you would have to put in friction. Maybe they say it's frictionless. So you have to just do an analysis for each of these, but keep in mind your equivalencies. Does the whole system, if it's a whole system, it's going to have the same acceleration, but this box won't necessarily experience the same force as this box. So the forces will be different, in fact. Okay, that is our multiple system sample problem. Thanks for watching. Take a crack at the homework and have a good day.